Hello everyone, welcome to another video of chapter number 1, that is of solid state, and in this lecture we will discuss about the numerical portion of density based numericals. Okay, so in this lecture we will discuss about the numericals, all that numericals we will discuss here. In last lecture we have discussed only one numerical, and for the calculation of that numerical I have given to you all. Okay, so answer was 63.1 obviously. So now here we will discuss about the next lecture, and from that beginning section I will once again explain the formation of formula, means that we will derive the formula of density, and afterwards we will move on the question part. Okay, some students were asking about the number of questions. Okay, means they were just asking about the that one student has comment on the video, or maybe in the doubt counter he has commented that sir, please give some problems so after the lecture so that we can do the practice at home. Okay, actually the question which we are discussing here, no, that all are for you all. Whenever we are teaching, what you have to do, when you will see the question, you have to pause the video and just do yourself first. Okay, try to do yourself and then you can see the solution. Okay, in that way you can learn it, learn that concept properly. Okay, then firstly, whenever you are seeing the video, whenever you are seeing the question after the concept, related to the concept, then you have to pause the video, and afterwards what you have to do, solve it, try to solve it. It may be wrong. Okay, so afterwards if you will see the solution once again, then you will see that mistake that you have done, and in future time you will not do that mistake once again. Okay, so try to do yourself first and then see the solution. Okay, clear? That's why what continuously I am saying, try to do yourself by pausing the video. Afterwards you can see the solution, and try to do the calculation yourself first. Okay, I will not do that all calculations for you all. In this numerical section you have to do all that calculation yourself. Okay, clear? At last I will just give you that answer, because so many questions will be there that we have to cover in the short span of time. Means in this all that lectures will be up to 45 minutes maximum. Okay, so we have to cover all that syllabus, and you can see the topics. My just approach is like in this way, means I have to cover at least one topic in a given video, so that you can understand all that topic in the proper way. If I will continue that video in small sections, that will be not possible for you to understand. Firstly, for that you have to watch that previous video, then you have to come to this video. Okay, in that way you can understand properly. So what I am saying, if you are watching a single lecture, you should learn at least something. Okay, something you can learn from that video at least, according to me. Now in this lecture we will discuss about the numerical problems of the density part. Okay, density, that one numerical we have discussed. Okay, that is calculation involving the unit cell dimensions. What was that? In that section what we have discussed, density is equals to mass over volume. Yes or no? Okay, density is equals to mass upon volume. Okay, then volume of unit cell. Okay, density of unit cell we are discussing, no? So the volume of unit cell is, see, this one is the unit cell. Okay, and it is having edge length A. So the volume of unit cell which is in cubic shape will be A cube. So the volume will comes out to be A cube. Now we have to calculate the mass. How we can calculate it? Mass will be equals to mass of unit cell. It will be equals to the number of particles into mass of a single particle. Okay, number of particles and into the mass of a single particle, that it will comes out to be the total mass of unit cell. Okay, then Now how we can calculate this mass of the particle? The mass of a single particle, how we can calculate it? Yes, tell me. Here we can do one thing, we can calculate it. I will just explain the mole concept little bit now once again. Okay, to mole, if you have the number of moles, to calculate the number of particles you have to multiply it by Avogadro's number, then you will get the number of particles. Okay then, and if you have the number of moles, you can if you want to calculate the mass, then you have to multiply it by molar mass, and if you want to calculate the number of moles from mass, you have to divide it by molar mass, and if you calculate the number of moles from number of particles, you have to divide it by number of particles. Okay, that Avogadro's constant. Now if you have the number of particles, okay, like Na is the number of particles which is equals to 1 mole, it will be equals to molar mass. Okay, means the Avogadro's number of particles have the mass equals to the molar mass, gram molar mass, and for one particle, mass will be equals to molar mass upon the Avogadro's constant, that I have discussed in the previous lecture also. For the one particle, the mass will be equals to the molar mass upon Avogadro's constant. So here I can write Z into molar mass upon Avogadro's constant. Okay, total mass. So now density will comes out to be, mass is Z into molar mass upon Avogadro's constant into volume is AQ. So the density is Zm into Zm upon AQ upon into Na. Okay, clear? So the formula comes out to be density, that is rho, or you can write in the form of small d. Z is the total number of particles in unit cell. M molar mass, okay, molar mass of the element which we are using for the particle, and A cube, A is the edge length, okay, and Na is the Avogadro's constant, whose value is 6.02 into 10 raised by 23. Okay then. Now we'll do the numerical portion here. That numerical we have discussed already. Okay, so we'll do that fastly now. What we are having in this section, X-ray diffraction study shows that the copper crystallizes in FCC unit cell. Okay, so if it is FCC, means Z value is 4. All of you know that how it comes. Okay, with cell edge cell is, means A is equals to 3.608 angstrom. Okay, means it comes out to be 3.608 into 10 raised power minus 8 centimeter. In a separate experiment, copper is determined to have density. The density they have given to you, that is density 8.92 gram per cubic centimeter. Okay, then calculate the atomic mass or molar mass. Okay, means that M you have to calculate. Na value is 6.02 into 10 raised power 23. Actually in the numericals it will be given to you. Okay, if it's not given, you have to take this value, and sometimes they will give they can ask you the value of Na, so in that way you can't suppose that value. Okay, so now the formula is density is equal to Zm upon A cube into Na. Now what we have to determine? M. So M will be equals to rho into A cube into Na upon Z. Value of rho is 8.92, okay, into A is 3.608 into 10 raised power minus 8 cube into 6.02 into 10 raised power 23 upon Z value is 4. So do that calculation. Okay, try to do that calculation here. So answer will comes out to be 63.1 units. Okay, clear? Okay, so if you want to note it down, you can note it down now. Now next question. Silver forms CCP lattice and X-ray studies of crystals show that the edge length of the unit cell is 408.6 picometer. Calculate the density of silver, and atomic mass of silver is supposed to be 107.9 units. Okay, that is the value given to you. Okay, so now what we can do, see, see the silver forms CCP. CCP lattice means which is equals to just FCC. Okay, so the Z value will comes out to be 4 here once again. Yes or no? The value of Z will be 4 here. Okay, then firstly you can write that formula. Okay, rho is equals to Zm upon A cube into Na. So rho what? Okay, that we have to calculate. Okay, Z, okay, given m atomic mass, that is 107.9 units. Okay, then A edge length, this one is A is equals to 408.6 into 10 raised per picometer, so it will be minus minus 10 centimeter. For picometer it will be 1 picometer is equals to 10 raised power minus 12 meter, and in terms of centimeter it will be 10 raised power minus 10 centimeter. Okay, so 1 2 3 4 and Na 6.02 into 10 raised power 23. Now what we have to do, that rho we have to calculate now. So rho will becomes equals to Z 4 into m 107.9 upon A is 408.6 into 10 raised power minus 10. Okay, Q Na, that is 6.02 into 10 raised power 23. Okay, so you have to do that calculation. Do that calculation. Solve this calculation yourself first. Yes, run. Huh? So the answer will comes out to be 10.5 4.86 into 10 raised power minus 10. Okay, so answer will comes out to be, that will be 10.5 into 10 raised power 3 kilogram per cubic meter, or you can say 10.5 gram per cubic centimeter. So that will be more appropriate as compared to this one. So answer is comes out to be 10.5 gram per cubic centimeter. Okay, then clear. So shall we move to next question? So next question is, an element has molar mass. Now molar mass is given to you. Form a cubic unit cell. Okay, it will form cubic unit cell with the edge length 405 picometer if the density is 2.7 into 10 raised power 3 kilogram per cubic centimeter. What is the nature of cubic unit cell? Okay, now what they are asking about the nature of cubic unit cell. Nature of cubic unit cell. How we can justify the nature of cubic unit cell? You have to just calculate the value of Z here, and if you will calculate the value of Z, that if it is 1 means it is of simple cubic, if it comes out to be 2, then it is body centered cubic, and if it comes out to be 4 or nearby 4, it will be face centered cubic lattice. So here just we have to calculate the value of Z. Okay, so formula, firstly once again you have to write the formula here. Density is equal to Zm upon A cube Na. Okay, so what they have given to you, molar mass they have given to you. Okay, so molar mass M is equals to 2.7 into 10 raised power minus 2 kilogram per mole. Okay, then next one is what they have given to you, that is with the edge length. Edge length is given, that is A 405 picometer means into 10 raised power minus 10 centimeter. Density is also given to you, rho is equals to 2.7 into 10 raised power 3 kilogram per cubic meter. So here you can take the meter, in terms of meter you can take. Okay, A should be in terms of meter, you can take 405 into 10 raised power minus 12 meter, and because the here meter that units are in terms of meter, no, so that's why I am taking meter. So 2.7 into 10 raised power 3 kilogram per cubic meter. Okay, then what is the nature of cubic units, sir? Means Z value you have to calculate, and A is equals to once again 6.02 into 10 raised power 23. So sorry, so now see, Z comes out to be rho into A cube into Na upon M. Now value of rho 2.7 into 10 raised power 3 into value of A 405 into 10 raised power minus 12 cube into Na 6.02 into 10 raised power 23 upon value of M 2.7 into 10 raised power minus 2. Now solve this value. Okay, solve this value, try to solve this value. So answer will comes out to be, that answer will comes out to be I'll give you that answer now, just now. Yes, done. So the answer will comes out to be approximately equals to 4. So if it is 4 means if it will be FCC cubic lattice. The nature of cube will be, the cubic cell will be unit cell will be FCC or CCP or CCP. Okay, then actually answer will comes out to be 3.99 and it will be approximately to 4 you can take. Okay, so it will be equals to the nature, that is which is equivalent to the FCC or CCP. Okay, then now next question you have to try yourself first. Same question is there that we have already discussed. The element with density 2.8 gram per cubic centimeter forms a FCC unit cell with the edge length this. Okay, calculate the molar mass. Same question is there, that is for you. Those are asking, no, means sir give some problems to solve at home so that you can practice it. This question you can do it now. Okay, whenever you in the class you can, if you can do the questions now, means here you feel little bit pressure, and in that pressure you can solve that with 100%. Okay, so here same formula is there, Zm upon A cube Na. Okay, so element with density is given to you, rho is equals to 2.8 gram per cubic centimeter. Okay, then forms a FCC unit cell. FCC means Z will be equals to 4. Okay, then edge length is given to you, A is equals to 4 into 10 raised power minus 8 centimeter. Okay, then molar mass you have to calculate. Okay, Na will be 6.02 into 10 raised power 23. So the formula will be m is equals to formula will become rho into a cube into Na upon z. So what is the value of rho here? What is the value of rho here? 2.8. A cube. What is the value of a here? What is the value of a here? See that. 4 into 10 raised power minus 8. 4 into 10 raised power minus 8. Okay. And Na 6.02 into 10 raised power 23. Z value is 4. So solve this value. Try to solve this value. Answer I will provide you. So try to solve this value. Once again I will say that try to solve this value yourself. Okay. So answer will comes out to be 26.98 gram per mole. Okay. 26.98 gram per mole, or it will be approximately equal to, you can say, 27 gram per mole. Okay then, can you do this question? Okay then. Okay, now try to solve this question yourself. That is just little bit tricky. Try to solve this first. Okay, just try it. Okay done. So now we can do this once again, similar way. Density of copper is given to you. Okay then, so density formula, firstly you can write Zm upon a cube Na. Okay, so here density is given to you 8.95 gram per cubic centimeter. Okay then it has FCC structure. FCC means Z will be 4. Okay, what is the radius of copper atom? Now R we have to calculate. How we can calculate R? What type of question they are asking here? Okay, that question we have discussed a little bit similar to that question we have discussed in the previous video. Okay, that first numerical that we have discussed in this previous lecture. No, if you just want to solve this yourself, try to check that video. Here just you have to calculate the value of A. Firstly you can calculate the value of A with the help of this formula. So A will be A cube is equals to rho Na, it will be Zm upon rho into Na. Okay, so in this way you can calculate the value of A cube. And how we can calculate it? By cube root. Okay, cube root, you have to do that cube root here. Okay, in this way you can calculate the A value. Now FCC structure is there, no? Packing efficiency, remember that particles here. Okay, so it will be 4R equals to 2 B is equals to 2 root 2 A. 4R is equals to root 2 A. So A will comes out to be 2 root 2 R. That was the relation we have discussed there. See there. Okay, in the previous lecture, or in your notes you can see the A is equals to 2 root 2 R. That was the relation there, no? So now here what we have to do, radius we have to calculate. So R will comes out to be A upon 2 root 2. So from this formula you can calculate the value of A, and afterwards you can from this value put value of A here, and you can calculate the value of R through it. Okay, try to solve this yourself. Okay, try to solve this yourself. Yeah, clear? So answer will comes out to be that answer I will provide you now. So answer is 128 picometer. Okay, if you can't solve it, you can just put it on the doubt counter. If you are having doubt in this section, once again I will provide the solution of this question in the next video. Okay, just calculation you have to do, or you want that calculation once again. See how we can calculate it. I can solve it now. The formula will comes out to be A is equals to Zm upon rho into Na. Okay, Z value is 4, M value is 63.5. Okay, rho value 8.95 into Na 6.02 into 10 raised power 23. Okay, yeah. So this one is the A cube. Now you have to solve this calculation. Can you solve this calculation here? So that on solving this calculation, you will get the value 4.71 into 10 raised power minus 23. That is the value of A, and here the units will becomes cubic centimeter. Now it is the value of A cube. For A it will be 4.7 into 10 raised power minus 23 cubic centimeter root. Okay, so it will comes out to be 3.6 into 10 raised power minus 8. Now that we have calculated here now, so R will be equals to A upon 2 root 2, 3.6 into 10 raised power minus 8 upon 2 into 1.414. So can you solve this value at least? So answer will comes out to be 128 picometer, that we have discussed already. Okay, done. Next question is next question is an element with density 11.2 gram per cubic centimeter forms a FCC lattice with edge length of 4 into 10 raised power minus 8 centimeter. Calculate atomic mass of element. Okay, so that question is for you all. You have to solve this yourself. Okay, so once again that same formula is there. Calculate atomic mass. So it will comes out to be rho into A cube Na upon Z. Value of rho given to you 11.2 gram per cubic centimeter. A value of A is 4 into 10 raised power minus 8 centimeter cube. Na 6.02 into 10 raised power 23. Okay, and value of Z, which type of lattice is this? FCC 4. So solve this calculation here. So answer will comes out to be 108 gram per mole. Okay, clear? Next question you have to do yourself once again. Iron has body centered cubic unit cell. So many times some students will think I'm just supposing that some students were thinking about the sir have given the numericals just related to the FCC arrangement. Now it's body centered. Okay, so iron has a body centered unit cubic unit cell with the cell dimensions of 286.65 picometer. The density of iron is 7.874 gram per cubic centimeter. Calculate the value of Avogadro's numbers. We have to calculate that thing we have to calculate, which we already know. That is, you can say that वो कहते हैं ना चांदी हो गई. So means which value we have already crammed, we have already in our blood, that we have to calculate. That type of question they are given to us. So now the density of iron is 7.874 gram per cubic centimeter. Calculate the value of Avogadro's number. mass of iron is given to you, that is 55.84 gram per mole. So directly you can answer that question. Rho is equal to Zm upon A cube Na. Na we have to calculate here, no? So Z for BCC, Z is 2. Okay. M molar mass is 55.84 gram per mole. Okay. A value of A, where is value of A? That is 286.65. 286.65 into 10 raised power centimeter, no? So minus 10 centimeter cube. Okay, and then value of rho density 7.87 into nothing. Okay, now solve this value directly. Solve this value. Can you solve this value now? So answer will comes out to be same, that is 6.02 into 10 raised power 23. Clear? Yes, done? Any doubt here? What happened here? So that is the end of this lecture, and at last I will provide you some questions after the completion of this chapter. Okay, at last we will do the back exercise, previous year questions, assertion reason based question, MCQs. Okay, so many questions we will discuss in the upcoming lectures. Okay, now you will get all that lectures regularly. Okay, during last time I was just feeling bad, my health was not very well during that time. So now you will get all that lectures on the time. Okay, so if you are having any query, you can post it on the doubt counter. Okay, if you are having any query about the lecture, so if any problem is there, if any improvement is there, then you can share with us. Okay, so if you are having any doubt in the related to these topics, means you are following any other books, some other questions, okay, so that you can post there, and I will surely reply for that questions. Okay, so at last, once again I will say that thanks for watching this video, and keep studying, keep motivated, stay at home. Now you can see that situation around you. Okay, so many drastic situation you will feeling there. Okay, you can face, don't face that. I would suggest you, don't face it, don't go outside. Okay, if you are going outside, use that double mask, because this is a second strain. Okay, so you can use that double mask if it's possible, because nowadays you will see that so many bad scenes coming in front of your faces, in even in the news channels you can see there. Okay, so at last, once again I will say, stay at home. So thanks for watching this video. Thank you.